Hello and welcome to the course Signals and Systems. I am Dr. Zishan Karim from Electrical Engineering Department, CUIUA campus. Okay, let's move to the lecture contents. In this video, we will cover two main topics. First one is the combination of shifting and scaling, and the other one is the amplitude scaling. Okay, let's move on. What is combination of scaling and shifting? As we already studied in our previous lectures, that we can either scale the signal or we can either shift the signal. But what about if we have a type of a signal where we require both of these properties, like the scaling and the shifting? As we already discussed, for the scaling, if we have some signal x of t and we would like to scale that one, for example, we have a signal x a of t. So if a is greater than 1 here, so it means that we are compressing the signal, and if a is less than 1 here, then it means that we are expanding the signal. We already studied this property. And what about shifting? For example, if we have a signal like this one, x t plus 1, then it means that we are shifting the x of t to the right by 1, right? We are shifting the signal to the left by 1, not right by 1, sorry, left by 1. And if we have a signal like this one, x t minus 1, so it means that we are shifting the signal to the right by 1. So it is kind of a delay, right? And this one is advanced. Now we are in this slide, we will look at the combination of shifting and the scaling. How if both of these operations exist in a one signal. So there are two methods to solve these kinds of signal. First one is called the scale and then shift. It means that first we have to scale the signal by using this kind of properties, and then we have to shift the signal by using this kind of property, right? So let's see by an example. If you have a signal x of t given this one, right, this is the shape of a signal, and we have a given we want to plot the x3t plus 4 out of this x of t. So there are two things. One is scaling factor. Here scaling factor is 3, and the other is the shifting factor, which is currently, if you see that independently these two signals, this signal as an independent signal, then there is a shifting by 4. So by first method, if we adopt the first method, which is scale and then shift, so how it works? For example, we call this A3 here alpha to generalize that equation. So we have x alpha t plus beta. So alpha t, for example, alpha 3 here, and t is t, and the 4 we replace by beta. So for scaling and shifting, let's take the alpha common here. So if we take the alpha common here, then the signal becomes t plus beta over alpha, right? So this first one is called scaling factor, scaling, and then this one we have to shift by beta by alpha. So in two steps we will perform this operation. First we will by method 1, if we are focusing on method 1, so first we will do the scaling by alpha to the given signal. For example, the given signal is x of t, right? And then after getting that result, the shifted version, for example x alpha t, we all achieve that one. Then what will we do? We will do the shifting by beta over alpha, right? X alpha t we achieved, right? So the by doing the scaling fact first, then we will do the shifting. The other one is the opposite one. Like first we do the shifting. So for shifting, for example, xt plus beta, we do the shifting because no role of alpha here, as we are not doing the scaling. So with the existing, for example, xt existing, so we will just scale with the given 4 here. for example. So after shifting it, we will just do the scaling with the output signal. So it will be x alpha t plus beta. So here we don't have any division or multiplication with alpha again. Okay, let's solve this example one by one by method 1 and by using the method 2. Okay, look at the same example here. We have x3t plus 4 given signal, and by method 1, if we want to solve this one by using the method 1 is scale then shift. So as we discussed in the previous slide, we have to take the alpha common here. So we took the alpha common here, so it becomes x3. So this is the scaling factor, right? And then 3t plus 4 over 3. This is our shifting factor. So first we will do the scaling. So x3t scaling means that for the given signal, we have a given signal on the previous slide. We have a minus 1 here. So as we discussed earlier, so if we want to do the x3 of t like this one, what we will do? We will divide the given signal by 3 to get the compressed version signal. So by dividing this one, for example, minus 1 by 3 and 0 by 3, so there we have a 1, so 1 over 3, so 2 over 3. So this is the scaled version of the x of t we obtained, right? And after getting the scale version, we have to shift by which factor? The factor is 4 over 3. So this signal, not the previous one, except we will scale, we will shift the scaled, already scaled version by 4 by 3. So what does 4 by 3 means here? So you have to, it means that when there is a positive sign here, so we have to, it will move to the left. So we have to subtract this x's like minus 1 by 3 with the minus 4 by 3. So minus 1 by 3 minus 4 by 3, it will become minus 5 by 3, right? Similarly, for 0, 0 minus 4 by 3, 0 minus 4 by 3, it will become minus 4 by 3. It will shift to the left. And then the other one is 1 by 3. So 1 by 3 minus 4 by 3, it will become minus 1, right? Simple calculation here. So 2 by 3, so 2 by 3 minus 4 by 3, it will become minus 2 by 3. So we have a final signal look like this one. So what is this signal? This is actually the scaled and the shifted version of this. So we obtain x3t plus 4. So this is the representation of x3t plus 4 after performing two operations. First one is the scaling and then shifting. Okay, let's solve this similar example with the shifting and the scaling version. Okay, for shifting and scaling, as we know that first we have to shift. So shift by the factor 4. So plus 4 means that it will be shifted to the left by 4, right? So left by 4 means we have to subtract with the original signal with minus 4. So previously there was a minus 1 here, so minus 1 it become minus 1 minus 4, it would become minus 5. So then previously it was 0 here, so 0 minus 4 it become minus 4. It previously it has a minus 1 plus 1 here, so plus 1 minus 4, it is equal to minus 3. Previously it was here 2, so 2 minus 4, it will become minus 2, right? Now after completing the shifting, we have to scale by the this signal. If for example we name it as a z of t. So we have to scale that z of t by which vector? By 3, right? So it is, so we are we are doing scaling of z of t, right? Not the x3t plus 4 or not the x of t. So we are doing the scaling of z of t. So z of t means we have z of 3t. So we have to obtain z of 3t from this signal, right? So for example, we named it as a y of t. So y of t equals to z of 3t, right? So z of 3t means already obtained signal. This one we have to do compression by 3t. So compression means divide the factor minus 5 by 3, right? This one by 3. So minus 4 by 3, right? And minus 3 over 3, it becomes minus 1. Minus 2 over 3, it becomes minus 2 over 3. So it is shifted, it is compressed to the these values, right? So if you check and verify from the previous slide, we obtained the similar results, this one for this x3t plus 4 by using two different methods. So this method is one of the important method called which is a combination of scaling and shifting, but we can solve the similar example by using two different ways. One is called scale shift and the other is called the shift and scale. Okay, this is another example to clarify, to clear the idea which you get from combination of scaling and shifting. Okay, for example, you have a signal x of t and you want to obtain the signal x2t plus 1, right? So you have to plot the signal x2t plus 1. So similarly, we have two methods. First one, scale, then shift. So for scale and shift, you have to take the two common here. For example, two common here. So it becomes x2t plus 1 over 2. Signal will look like this way, right? So first you have to do the scaling. So scaling this signal by 2, it means that you have to divide by 2. So if the same axis will divide by 2, it will be minus 1 by 2, right? 0 will be 0 and 1 will be 1 by 2 and 2 will be 1. So it is x2 of t, right? So we obtained this one. So by obtaining this one wt, we have to do the shifting by 1 of 2, right? The factor is 1 by 2. So by shifting means that we have to shift plus 1 by 2 means we have to move this one to the left, which is called advanced, right? So minus 1 by 2 minus 1 by 2, which is already, so minus again 1 by 2 because we have a factor of minus 1 by 2. So if we do minus 1 by 2 minus 1 by 2, it becomes minus 1. For 0 minus 1 by 2, it becomes minus 1 by 2. And for 1 by 2 minus 1 by 2, it becomes 0, right? And for 1 minus 1 by 2, it becomes 1 over 2. So this, by using the method 1, scale and then shift, we obtain the signal x2t plus 1. So this is the shape of x2t plus 1, but we performed in two steps. First is scale, then shift. Let's solve the same example by another way, shift then scale. For shift, you have to just shift by 1. So 1 means move this original signal, this one, to the left by subtracting minus 1. So minus 1, we have minus 2. For 0 minus 1, we have a minus 1. For 1 minus 1, it will become 0. And for 2 minus 1, it becomes 1. So it is advanced version of this signal. So it is first shifted to the left, and then we have to scale. For scale, like we obtained this vt, so we have to scale this one by 2, so to get the v2t, right? So it means that we have to divide this axis by 2. So by dividing this one, we have a minus 1 here. By dividing minus 1 by 2, it becomes minus 1 by 2 here. By dividing 0 by 2, it becomes 0 again. and for 1 divided by 2 we have a 1 over 2. So this was the example to clarify more your ideas, and this is an example of combination of scaling and shifting. There is another operation which is called amplitude operation. Amplitude, previously we were doing scaling, shifting, and we are touching inside x of t, like we are doing x2 of t, x3 of t, so on. Now we are just doing multiplying this with the a of, right? We are multiplying this with a, which is called the amplitude factor, right? And the b, what is b? B is just doing the shifting up and down. For example, this is your xy axis, and if you have this line, right, if it is not passing through the origin, it means that it is shift by, if b is positive, if it is shifted to up. For example, if it is crossing the y-axis at 1, so here b is 1. If it is 0, so it will look, if b is 0, the same function will pass through the origin and it will look like this one. This is the case for b equals to 0, right? And this is the case for b equals to positive 1. And similarly, we can plot the same equation, b equals to minus 1, for example, right? This is minus 1. So it is not passing to the, or it is touching y-axis at minus 1. So this is the adjustment of the y-axis by using b factor. So it is b equals to minus 1 case. So this in general yt equals to axt plus b. So for this we use b greater than 0, b less than 0. So these three plots are to explain the b factor, effect of the b factor. The other one is the ax of t. So we already discussed b. Now focus on the ax of t part. Here we have an amplitude scaling. So if we have an amplitude greater than 1, we will get, it is called gain. And if alpha is a is less than 1, it is called attenuation. Look at this equation, this one. For example, you have a x1 of t signal. So if we multiply with some factor a here, so what will it do? It will just, for example, here a is equal to 2. So it will scale the amplitude by 2. It is not, look at this, the time axis is same, minus 1, 0, 1, here minus 1, 0, 1. It is not moving the x-axis, it is just scaling the y-axis because this is the amplitude scaling. So 2, so the existing amplitude at minus 1 previously was 1, at 0 it was 1. So if we scale by 2, so at minus 1 it is 2, at 0 it is 2. But for 1 it was 0. So similarly it is at 1 it is 0. But the other part is similarly scaled out as well. For example, if we have a similar signal x1 of t and we want to scale by a equals to 0.5. So for 0.5 scaling, what will we have? We have to at minus 1, look at these 3 points are same, at minus 1, 0, 1. There is no scaling, no shifting, but just the amplitude scaling, not the time scaling. So for amplitude scaling 0.5, so here it was 1, so it becomes 0.5, because 0.5 into 1 becomes 0.5, 0.5 into 1 again at 0 becomes 0.5, so 0.5 into 0 it becomes 0. So these are the two operations which we targeted in this video. One is called scaling and shifting, combination of scaling and shifting. The other one is the amplitude operation, which is related to the amplitude fluctuation rather than the time axis or the x-axis fluctuation. Thank you for listening. For question answer, there will be a separate slot and the exact time and date will be communicated later on. Thank you very much.